Hi, I'm Dan. I'm going to go over some of the math for our log splitter. As Nick explained, we came up with an in-process print, also our team print, which we'll go over later. With the print and our original specifications of 2,500 psi for our log splitter, a flow rate of 16 gallons per minute, with a diameter for our cylinder at 6-inch diameter. With those specifications, we come to our extension speed, and how we got that was our gallons of our per minute, converting that into volume, came up to 3696. Our diameter of our cylinder with its area came up to 28.3. Divided, we get our speed of 2.2 inches per second, or 130 inches per minute. With that information, we determined our horsepower. Our gallons per minute times our PSI times the conversion of 0.00583. And that came up with 23.32 or 25 horsepower. But as our team concluded, that was probably only going to be used at 80% efficiency, so we determined 29.15 or 30 horsepower. With that, we decided on a 3/4 inch inlet line is a -12, a return line of 1 inch or -16. So our flow rate for our pressure lines is a 16 gallons per minute times the conversion of 0.3208 divided by the area of the -12, which comes up to 11.6 feet per second. From there, we determined our original tank size was going to be 35 gallon, and how we came up with 35 gallon was 16 gallons times 2 is 32 gallons. Then we wanted to compensate for all the lines and the filters, and we determined roughly 3 to 5 gallons for that. And our cylinder, back up with our 36-inch stroke, 2-inch rod, we determined it's going to be 4.5 gallons for our cylinder. So with all of those together, we decided on a 45-gallon tank. From there, the fluid we decided on was the Chevron hydraulic ISO 10, based on the working temperature of 40 degrees Fahrenheit to 104 degrees Fahrenheit. Our ISO target clean code was determined based on a fixed vane pump of 18, 16, 13. Then to determine our BTUs per hour, the formula is 1.5 times gallons per minute times the PSI. And we determined that was only going to be used at 50% of the time, half the duty cycle, because when you're not splitting a log, you're loading the log, so it won't be ran continuous. So from that we determined it was going to be 30,000 BTUs per hour. Thank you.